Depreciation is the reduction in value of an object. A used car is not worth much as a new car. Oh, is not worth as much as a new car. Depreciation is typically described in the percentage lost in a year. So 15% depreciation loses 15% of the remaining value from one year to the next. The amount after depreciation is calculated as called the residual value. So if Sam bought a used truck from a friend and paid $10,000 for it, if the truck rate of depreciation is 15%, how much is it worth 1 year later? So we talked about yesterday how to do it in one step, right? So instead of taking 10,000, this is one way we could do it, right? Take 10,000, figure out what the 15% that you lose is, right? So what do I actually lose? So what's 10,000 times 0.15? You're losing $1,500, right? So then you would have to do 10,000 minus 1,500 that you're losing to come up with your new value. So it's really worth 8,500. So we talked about yesterday how instead of multiplying by an R value of 0.15, you can multiply it by the R value of what you're retaining. You're retaining 85% of the value, but you don't call it 85% depreciation rate. You call it a 15% depreciation rate, and then you do the calculation that you're keeping 85% of the original value. Oops, so 8,500. So see how you get the same answer? This is the way you want to do geometric sequences, because then you have an R value that you can raise to a certain number of years. So we're going to fill in the table. So let's track the rate of the depreciation over time. So the start of the year was 10,000, right? That's how much he bought the truck for. And we said after, this is kind of confusing, but we're going to say years after purchase. So 1 year after purchase, it's worth 8,500, right? So we're going to fill in this table. All you have to do is multiply the previous year times 0.85 to get the next year, and then the next year. Kind of do it recursively, right? Because you have 1 year at a time. Or you could use the table on your calculator. So fill that table in. And then at the bottom, it says, can you write this as a function, basically, or as a sequence? And number 5 says, what's the value after 15 years? So I'll give you a couple minutes to try that application problem before we move on to the back, right? So we might be off by a couple pennies because I used the table on my calculator, and if you multiply by like whatever you rounded to, like this, these are rounded answers. Did you get around 1968? Are we within like $1? Because we rounded maybe differently. And then did you write down the geometric? So it'd be, you're starting at 10,000 times 1.05. I wrote it to the X because they want it to be X years after. So if you do X, then when you plug in 1, it gives you it. Oh, wait a second. 1.05. I was thinking of that raising problem. It was 0.85, right? So I think I used the right values in my calculator. I did. So then when you plug in 1, you're getting the first year's depreciation. When you plug in 2, you're getting the second year's depreciation. So to me, I want this to be X years after. That's why I used X. And if I want the original price, I would plug in 0 for 0 years of depreciation. So you got to use some common sense when you're doing applications and figuring out that exponent. That can be tricky for sequences. So let's see, what's it have you do on the back page? So the back page, oh, they want you to graph the value of the truck over time. So let's just take a look on a graphing calculator and see, let's see, if we go from 0 to like 10 years and 0 to $10,000, I'll just show you what the graph looks like. Oh, syntax error. Oops. How did I mess up my equation here? So just reminding you that a geometric sequence looks like an exponential curve. That's what they were going to have you do, but we don't need to plot all those points if we could just see it on the technology. So if you just want to start at, it starts at $10,000, right? What do we say after 15 years, it's at like 8 something, right? So it's just kind of a exponential curve heading downward. Just kind of sketch a couple points, connect the two dots. Just get it in your head that geometric is exponential in nature. So this was exponential decreasing. So see if you can answer those 3 questions down below. So there are different values of a car that's depreciating. I guess they're all car depreciation. So see if you can figure out 7, 8, and 9 with your calculator and using the correct R value. 7 and 8. Is that what you guys got for 7 and 8? So the 23% depreciation is represented by 7.77, right? And then you're squaring it for 2 years because it says 2 years ago. And then this one was 16,000 to start, and depreciation is 18%. So I used 0.82 3-year-old car, and I got that. So we had trouble on that, or we solved this. Like, let's pretend that we know the rate. So our equation would have been 28,000, right, times our rate of whatever we're retaining. Like if that was 82%, to the 5th power, right, has to equal 16.5. So we need to use algebra to figure out that R value. So the first step is to get R by itself. So how would I get R by itself? Divide by the 28,000 on both sides. So R to the 5th power equals that fraction. What does that come out to? It hasn't come out to something nice. 16.5 divided by 28,000. 0.589. But that's equal to R to the 5th. So it's kind of like if it was R squared, you would have taken the square root of both sides. It's R to the 5th. You're going to take the 5th root of both sides of the equation, which is under the math key. If you look under the math key, it'll say x root, and then you can select the index of 5. So I like to hit the 5 first, then hit the math key, the x root. So then it's going to take the 5th root of, I'm just going to go grab my whole decimal. If you want to round it, you could, but I like doing the whole thing. Yeah, so 0.8996 is what you're retaining every year. If you just find the difference between that and 1, it's like finding the difference between the percent and 100%. So the R value is 1 minus that number, right? Because 1 represents 100%. So if you do 1 minus that number, the R value would be 0.1. So 10% is the depreciation rate, right? Because this is the retention rate, and this rounded to 90% retaining the value. So you're losing 10% of the value every year. So 0.8996 is about 90%, right? So it's depreciating 10%. That's what you're losing, right? The R value is what you're retaining every year. Depreciation is therefore what are you losing every year. So that was a tough one. All right, so now you've got like what, 20 minutes, and I put up 4 recursive practice problems on the board because I think you need help with recursive.